Hello, my name is Carla Biley. I'm a doctoral student, and I've currently taught forensic science for the past 8 out of the 10 years I have been teaching at my current school. My presentation today is on explosives and forensics. We're going to start by first going over the agenda. We are going to cover what is an explosive, then we will look at how an explosive works, then we will look at types of explosives. Then we'll spend a little bit of time talking about explosive detection, both before and after the device detonates. Then we will look at examining the bodies of explosion victims. I will go through a forensic science lesson that I have used with my students. Then we're going to look at our case study, which is on Pan Am Flight 103. The question being, could a circuit board have been part of the IED? Then I will give you my reflections of the case study and finish with going over a conclusion. So before we get into the details about how to solve crimes involving explosions, we must first define what an explosive is. So according to the ATF, otherwise known as the Bureau of Alcohol, Tobacco, and Firearms, an explosive is any chemical compound, mixture, or device, the primary common purpose of which is to function by explosion. According to the textbook that we have used at my school, an explosion is a chemical reaction that releases a large amount of gas and energy very quickly. It is either an oxidation reaction or a decomposition reaction. Most explosions are oxidation reactions, though some decomposition reactions release enough gas and energy for an explosion to occur. Now that we have discussed what an explosion is, let's look at the science behind how they work. Gas and energy are released as a result of a chemical reaction. This chemical reaction causes a pressure wave known as a longitudinal wave. A longitudinal wave acts in the same manner that a spring would, where it has compressed areas known as compressions and more spread out sections that are called rarefactions. These waves cause air particles to move back and forth at high speed, which causes the damage that you see in an explosion. Some explosives are held in a container, such as a pipe bomb. When the pressure builds inside the container bursts in fragments, releasing particles known as shrapnel in every direction. Sometimes, when people make their own homemade bombs, they will put things like nails and glass in it to increase the amount of shrapnel that is present and cause maximum amount of damage. Take a look at several different types of explosives. According to the ATF, there are three types of explosives: high explosives, for example dynamite; low explosives, for example safety fuses and black powder; and blasting agents, such as ammonium nitrate fuel oil and some water gels. We're going to look a little bit more into detail between high and low explosives. Low explosives need to be contained in a container in order to explode, and high explosives do not. High explosives are further divided into two categories: primary and secondary high explosives, with primary high explosives being highly reactive and secondary high explosives being relatively safe to handle in comparison. Now that we have determined what an explosive is and the types of it, we're now going to look into how to detect them, both before they explode and how to detect explosive chemicals if an explosion has actually occurred. With the rise of terrorism, it has become even more important to detect explosives before they detonate. Given the recent withdrawal of troops from Afghanistan and Iraq, along with the current war in the Ukraine, there are more military-grade weapons and explosives available for those who wish to engage in terrorist activities. Even when a terrorist can't get a hold of military-grade weapons, they can improvise using common household materials and making what are known as improvised explosive devices, or IEDs. A person creating an explosive device does not need a large amount of explosives in order to cause damage. So this is one of the problems with detecting explosives. So detective devices must be able to detect minute amounts of explosives. First type of explosive detectors are called vapor detectors, and they detect vapors in and around the explosive. However, it can be difficult to identify vapors using traditional equipment because vapors scatter at the surface. In other words, where they touch the air, they spread out. Researchers have found that using silver nanotubes to detect vapors is more effective than using traditional surface-enhanced Raman spectroscopy. There are bulk detectors such as X-rays that are used to detect explosives as a whole. There are also detectors such as immunoassays, fiber optic biosensors, and empiriometric gas sensors that are used to detect hazardous chemicals that are found in an explosive. In addition to explosives that were recently put there by people who wish to cause an explosion, we also have to remember that in countries such as Vietnam and Cambodia, and in a lot of countries in Africa, there are also landmines, which are explosives that were planted in the ground and never exploded during a war. We use various methods of detecting these, such as anomaly detectors, vapor detectors, and bulk detectors. Explosive detectors on the scene with a suspected explosive device need a way to do the sort of testing of materials that would normally be done in a lab. So in a lab, you would, for instance, take a sample and put it through a spectroscopy machine or a chromatogram and try to determine what it was made out of. But in the case where we have a device where it may go off at any time, we need something to be on the field and be able to work quickly. One such device is a portable near-infrared spectroscopy, which allows investigators the opportunity to determine if explosive materials are present. This machine has reduced the amount of false positive results, saving money. However, with old materials or in poorly made homemade explosives, the NIR might not be able to detect explosive materials, leading to false negative results. Although our technology for explosive detection has improved over the years, investigators still rely on canines to assist in detection. In order to detect explosives, the dogs must be trained to identify common chemicals found in explosives. There is a problem with this, however, and that is that they cannot use functional explosives because a lot of the training areas take place near where people live and work. As a result, researchers have had to develop materials that smelt like the real explosives but were not as dangerous. Unfortunately, it does happen where not every explosive device can be detected and disarmed before it explodes. So if investigators do not get to the scene before the device explodes, they need a way to determine what pieces were part of the explosive, especially in an IED. They can't exactly take all of the soil and all of the burnout material from an area, especially if it's in a large area, so they need to be able to focus on what is most important. One of the problems that investigators have had is analyzing material in a timely fashion. One solution has been to use the direct analysis in real-time mass spectrometry, or DART-MS. This machine has the portability and prompt analysis that investigators need to make a decision in field as to what to collect and what was not a part of the explosive device. While it is true that most investigators will never come to a scene of an explosion, because the number of explosion victims is small, they do need to be prepared to look for clues in the event that one does occur so they can help solve the crime. And part of the things they look at is the actual bodies of the victims. One technology that we use is radiology, which can help investigators examine the victims for blast injuries and fractures, as well as for identification of the bodies, particularly those that have been the bodies have been severely damaged. Examining the bodies can help determine if the blast was self-inflicted, domestic explosions, work-related explosions, terrorist explosions, or explosions caused by accidents involving heavy vehicles. Now that I have covered some of the science behind explosives and explosive detection, I'm going to talk about a lesson that I have used in the past with my forensic science students. Now, our textbook does have a variety of labs suggested, but most of them would not be approved by the county as they involve the use of things such as fireworks and fire in general. However, there was one experiment that involved putting a piece of Alka-Seltzer and water in a film canister and placing the canister upside down on the ground. The pressure would build up until it reached a point that the canister and its lid would separate, causing the canister to fly through the air. Students enjoyed testing out various sized pieces of Alka-Seltzer to see how it would affect the explosion. In comparison to using actual fireworks, this experiment possesses only minor risks, which can be managed through the use of safety items such as safety goggles. This was done outside, away from the building and any cars, to further reduce the amount of damage that could occur. Now we are going to look at our case study. At first, we're going to look at a little bit of information behind the actual flight before we get into the forensic investigation. So Pan Am Flight 103 exploded on December 21st, 1988 over Lockerbie, Scotland, killing all 258 passengers and crew and 11 people on the ground. Part of the reason why it left people dead on the ground is because it left a trail of debris for miles. It was later determined that the explosion occurred as a result of a Samsonite suitcase located in the forward left-hand luggage hold exploding. As a result of the investigation, in 1991, two Libyan men went on trial for the bombing. The evidence was circumstantial at best, and there were those who believed that the men did not do the attack. At the heart of the debate is whether a piece of circuit board was found was part of a timer from Libya or not. Some people believe that the fragment could not have survived the blast and therefore was planted in the evidence. Others believe that the fragment did not belong to the timer from Libya at all. So this brings us to our main question, which is, could the circuit board have been part of an IED? So part of the reason why this is important to discover is because while it is not as common as it was between 1960 and 1990, plane explosions are still a real threat, with the most recent plane explosion occurring in 2016 with the Diallo Airline Flight 159. To better understand if it was possible for the circuit board to have survived the blast, researchers in this present study decided to test to see if it was possible. Bomb-filled suitcases were placed in a storage container similar to the cargo hold that was found on the plane, and were positioned in various ways around the spot where the bomb is believed to have gone off in Flight 103. That spot is known as the Clayton spot. In order to make sure that each of the trials had comparable results, the investigators placed objects in the suitcase in the same manner so that the original position could be identified. So, for example, the original suitcase is believed to have had shirts and other clothing material in it, and so stacks were similarly made into the test suitcases as well. The test suitcases in the various trials were placed in different locations throughout the cargo hold. After the test explosions, larger fragments were sorted by color and placed into large bags. The cargo hold was then vacuum cleaned for smaller particles. A sample of the fragments were then tested so that researchers could get an idea of what did and did not survive the blast, paying particular attention to the circuit board pieces. They were examined using compound microscopes and scanning electron microscopes. So now on to the results of the experiments. In the first experiment, 62% of the circuit board was recovered, while in the other experiments, between 9 and 12% were recovered. They did not explain why so much was recovered in the first round. The pieces that were recovered were blackened, and the glass fibers of the circuit board were melted. Researchers also found that the majority of the metal objects were able to be recovered. The aluminum pieces were cratered and pitted, while copper pieces were flattened. They found that the IED suitcases were found in more pieces than the surrounding suitcases were found in. So researchers concluded that it is very much possible for the fragments of the circuit board to have survived the bomb blast, meaning that the official findings could in fact be accurate. So here are my reflections on the case study. I do think it's important to review old cases, particularly those that were never solved or remain controversial. If you watch a lot of forensic science stuff like Forensic Files and programs like that, you may see that sometimes crimes are solved 10, 15, 20, 30 years after they occurred. So it is not too late to solve these old crimes. However, I would be careful about using this sort of material in a courtroom unless the researchers have forensic science backgrounds. I think there's a difference between what happens in the lab and what happens in the outside world, and that can be lost on jurors who do not understand the difference. In this case, they were doing a recreation and did not test out the evidence from the actual crash. So I think if it was to be used at trial, there should be a caveat mentioned that this sort of testing was what occurred. And I think that this kind of testing can be used in the future to bolster a case against a suspected terrorist so that there would not be as much controversy as there was in the case of Pan Am Flight 103. So now I'm going to give my conclusions for the whole conversation of explosives and forensics. Explosives are a favorite tool of terrorists, so it is important to understand what is an explosive, how to detect them, and how to determine if objects were part of the explosive. It is important that when an explosion occurs, that we take the time to analyze the debris so that there are no future questions about who committed the crime. Modern techniques can help us review old cases like the Pan Am Flight 103, further boosting up the credibility of forensic scientists in future cases. Here is the first slide of my references. Here is the second slide of my references. Here is the third and final slide of my references. I thank you for taking the time to watch my video, and I hope that you were able to learn something. I'm going to include a link to the PowerPoint in the description below, because I do know that my picture or my video has blocked off a little bit of the references. Thank you for your time, and have a good evening or morning or middle of the day.